we as developers and data scientists, what we can do is, the first thing that we can do is we can choose smaller models, right? So Karpathy, he is actually, the person who built this chat GPT thing. So he has a version of that, which is like very, very small called Nano GPT. So you can clone it and, um, train that to kind of get a gist of how you can train GPT and what you can do with it. Um, so first thing is, right out of the box, use smaller models. The second thing is if you want to use larger models, use quantization techniques like LoRa and QLoRa. What these does is basically these weights are stored in float 32. These might sound like, very small sizes, but when you just keep on adding up, each weight has multiple floats and things like that, it can saves you GBs of RAM if you just implement it. One simple comparison could be like, there was a model which was around 80 GBs. I used QLoRa on top of it, and now I'm able to run it only in 13 GBs of RAM. So that is the kind of compression you can get when you use these algorithms. The third option is that you can use ChatGPT APIs, but you can use tools like LangChain and Llama Index to kind of give context without fine-tuning the large language models, right? So I have trained a couple of models myself. So this 10 million parameter model, this is basically an advanced version of NanoGPT only. And I am training this on the Shakespeare dataset. Now this is just 30 minutes of training as compared to 1 month of training that they have claimed. So you can see that it is generating Shakespeare-like text, but still, the story does not make any sense. It is just random people, random dialects and things like that. But it is able to capture the structure in a very nice way. So even if we do not use it to generate text, what we can use it to do is we can use it for classification problems because we just want to understand the structure of a sentence, right? Or we can use it in image transformers. So there is VIT and use similar models to classify images because there we need to identify structures only. So like this is how this can be made useful. Now, on the other hand, I have a 3 billion parameter model. This is GPT-J 2.7b. On top, I have this 1 hour of training. So we can see I asked it the question that, uh, tell me the steps for making a lemon pie. So you can see that it is kind of, giving out the steps, but because it is just 1 hour of training, it is kind of a baby learning to speak. So it is saying some things and it makes sense to some extent, but it is not that right. So finally at the bottom, I have 3 billion parameter model with 8 hours of training. Ignore these random characters. So we basically kind of, tokenize it because we have a matrix, right? And different sentences cannot have different lengths. So what we do is we kind of append random words to the end so that we make it all of the same length. And then we have random separator tokens like this hashtag response is a separate token. So this tells us where the actual answer begins and where the actual answer ends, right? So we have separate tokens for that. So now I asked it 2 questions. I asked it what is the difference between a laptop computer and a personal computer, and we can see that it is able to now understand what a laptop and a personal computer is, and it is able to give us answer that laptop computer is a type of personal computer that is portable and we can and can be used for activities such as work, school, and entertainment. And the definition goes on. So basically, it is able to understand the difference between the two. Similarly, in our domain, I asked it the question so that I can check if it is having any knowledge about the domain or not. So I asked it, tell me the difference between machine learning and artificial intelligence. And as the output, we have that machine learning is a subset of artificial intelligence that uses data patterns and algorithms to enable computers learn and apply knowledge without explicit programming. It uses data and predictions, data to use make predictions, build models, and make decisions. So like it is able to capture domain knowledge as well. So further steps could be that you can fine tune it on, for example, your company's documents, right? And this 3 billion parameter model was using around 90 GBs of RAM without the quantization, and around like 22 GBs of RAM with quantization. So like there was a significant reduce. And also like we can see that this 3 billion parameter model is kind of good, but not that good, because in, you know, the corporate field, you need to be like very, very mature with your answers. So one simple example could be if I just, yep. So this is a chatbot arena example that I have. I was trying it during this break only, that is why. So we basically have two questions. I have provided it with a context, right? One is Claude 2. Claude 2 is, if you remember, the top leaderboard example. The second one is 70 billion parameter model. Now, if we look at this context, we cannot see any Phillips or Thermo Fisher, right? Or can we? I believe no, right? But still it is giving that as output, which means that it is hallucinating at some extent. On the other hand, it is also giving out Cisco. Now, even if, you know, Cisco is a client of Fast Factory and Fast Factory has this case study, we did not explicitly ask it to kind of give it, right? And we asked it to just give answer based on this context. So one of the major problems that these models have is they hallucinate like super quickly. So you have to have some, sorry, you have to have some sort of evaluation in place so that every answer that ChatGPT produces, you are able to moderate it to some extent, right? Even like in these two examples, we were able to see that it is giving us the right answer. But how can we be sure without reading? And if we have to read, how is it automated then, right? What is the point of artificial intelligence if we have to read each and every answer? So for that, we have several sorts of techniques by which we can evaluate these large language models. So I believe that is one thing that you could explore when you go home after this session, or I mean after the session ends. That is one thing that you should explore, right? So the same model is trained with QLoRa. Now this is a Google Colab free instance, so if you want to try this out, I'll be happy to share this notebook. I'll just have to find it out. And we can now use the same model which was using, you know, 90 GB, then 22 GB. Now it is now able to load and run on just, I guess, 16 GB. Google Colab has 16 GB of RAM. I'm not sure. But that is how good this quantization techniques are. So I just prompted it with hello, my name is, and I generated random strings. Now this is this is fine actually, because this is not a instruction following model. This is just a base model that we can further fine tune to follow instructions, right? Well, these models are not really good because when I ask it questions related to mathematics, it gets confused very, very quickly. So now this is an open source model. Now OpenAI's ChatGPT is quite good at solving mathematical questions, but still, you know, it hallucinates a lot of times. So, and I have some examples also, I believe, in the next coming slides. But this is a Guanco 33 billion parameter model, which was trained with QLoRa. Now, of course, when you reduce this data type from float 32 to float 8 and int and so on, we lose a lot of information as well, because like it is obvious, if we compress something, we are ought to lose some information from that. But it is like quite good at generating language. So I asked it, a llama entered in my garden, what should I do? and it is actually able to give me with a proper answer that makes sense, right? So based on your use case also, you have to choose what kind of language model you have to use, right? So that is also one thing you have to keep into consideration. So even in deep learning, multi-layered perceptrons, machine learning, according to your use case, you will be using different models, right? So one simple example could be, there was a project of object detection that I had to do a couple of months back. So now this uh, latest algorithms in object detection are of course YOLO V7 and so on, right? And SSD and things like that. But my use case was that I wanted to get more accuracy and time was not a foundation. So for this, if I go with YOLO actually is a very fast model. It gives out predictions in real time, but it is not that good accuracy wise. ResNet 50, which was released in I guess 2012 or 2013, that is to clarification questions or kind of, ask questions to itself and based on that generate new things. Then there is the same thing with LangChain and Llama Index, and the final one is to have like fine-tune ChatGPT itself. So they have an API wherein you can fine-tune ChatGPT on their server instance. It will cost you, but you don't have to pay for the infrastructure cost and everything. So the last option is that. So if I show you how just by changing how you prompt, the results improve. So on the left hand side, we can see that we just ask it a question and we get an answer. So this is called few shot prompting, wherein we give it an example and we have an answer, right? So I asked it this question, I gave an example that this is the question and this is the answer. Now based on this, what do you think should be the answer of this one? And the answer it generated was actually wrong, because its task is to just generate text, and maybe 27th probability was much higher than this one. In the second example, in the chain of thought prompting, I again give it the same example, but in the answer I actually give it the steps that it needs to follow to answer this question, right? So now when I ask this question, it forces GPT to reason to itself, right? So it basically mapped out, if 5 was written here, 23 is here, so I should frame sentence like this. And now when ChatGPT started to generate 3 plus 6, now the probability for 9 was the highest, right? So that is why we get 9 as the correct answer. So that is why mathematics is also so important, because if you understand the concept of probability in a well-versed way, you will be able to work with these models in a better way, right? So that was chain of thought prompting. Similarly, we have other sorts of prompting as well. Let me just check if I have the sheet with me. Right, so you guys can actually take a screenshot of this if you want. So these are the basic sorts of prompting techniques that you can use. So to go over it quickly, you can follow a persona wherein you tell ChatGPT that I am a software developer at this company, so that now ChatGPT knows that any answer that it should give should be technical and should be related to that, right? It could be question refinement pattern, like as in like you give it a couple of questions and it replaces it in a way that you are able to give some information but not a lot of information. Cognitive verification is basically if you want your business ideas to be verified. So there is a certain pattern that you can use to get ChatGPT to do that for you. You can ask ChatGPT to behave as an audience, and when you start giving a presentation, of course you'll have to type. ChatGPT will then start giving feedback to you on what you should improve and what should delete. Now, flipped interaction pattern is when you want ChatGPT to start asking questions to you. So one very good example could be that you ask GPT to take an interview of you, right? So you just prompted that I am so and so and I want to apply for so and so position. So I want you to take this interview and you can tell the difficulty pattern and topics that you want it to include and things like that. Few shot prompting, chain of thought, these all you know. React is basically, again and again thinking based on that act. So Auto GPT is one good example for that. And similarly, you can kind of go through all of these, and there are a couple of exercises as well that you could maybe um, consider when you want to do. So when I go to Auto GPT, oh, wrong website. Right. So this Auto GPT is basically asking the GPT model to think for itself, and it has separate agents for you. So what you can do is you can maybe connect it to Google News and Forex and everything, and then you can connect it to your share brokers API keys, and you can ask GPT to make trades for you based on the decision. So in this case, we have uh, a couple of agents, and we ask it to uh, one moment. Let me just pause it and so we basically ask it to search for AutoGPT. Uh, Not exactly actually. So we ask it to search for AutoGPT on GitHub, and then based on that, we want it to give its description, right? So now using this query, it generated some goals for it. So the goals that it generated is search AutoGPT, find the GitHub and figure out what the project is, explain what GPT is in a file named autogpt.txt, and finally terminate, right? So it has three agents. One is demo thoughts. So thoughts is basically what it is wanting to think. One is reasoning, which will try to reason for those thoughts. One is the planner that will plan for this. And finally, there will be one agent which will criticize their plan, right? So based on this, they will improve on their own. So now when we see that it is able to kind of run these commands and everything, um, it does not have a UI because of course they did not connect it with Chrome, but these are basically the results of Google search. Now they opened this gpt.com website. They are analyzing this page based on like chunking and everything iteratively. And finally, we should have the summary in this autogpt.txt, right? Yep, here we have it. So you can see just by kind of prompting it in a right way, having multiple agents and connecting it to the right APIs, you are able to kind of search the web and navigate through it, right? So AutoGPT is quite costly to work with because it sends a lot of requests. Just for this example, I believe they sent 8 to 10 requests to ChatGPT. So if you want to try it out, you can for sure. Else, usually we prefer LangChain or Haystack or some other implementation of these agents because they take into consideration how many requests you are sending, right? So by this, you can let it teach about certain topics to itself, and finally you have the output, right? So this Auto GPT is quite nice if you want to. I'll share this link with yourself. Moving back to the presentation. So I just spoke about LangChain, right? So not only LangChain, but to all of the agents, like even AutoGPT follows a similar route, even Haystack follows a similar route. It is just a concept of agents overall. So basically, the most important component is LLM. Like what large language model will you use? Will you use just OpenAI's ChatGPT, or will you be moving forward to use some open source model? So Hugging Face, Right. So Hugging Face actually hosts a lot of open source models, so you can use any LLM from there. Um, Actually, just GPT 2.7b also is hosted there if you want to use it out. Um, we have a concept of memory, as in like, do we want to consider the history when we are asking questions? For example, we ask it a question that actually matches with some context that we have with us. Then we ask it to rephrase, right? Now this rephrase will be going in as a separate request. GPT will not know what it has to rephrase. So the way they can do it is by, if we decide if we want to give the history, and we prompt it in a way that we include the history as well there. Right now, there is a prompt component, so they have certain prompt templates available for you if you want to use any one of that, or you can create your own custom prompt as well. And then they have a lot of agents. So if we go to LangChain, LangChain's documentation, go to agent. Oh, they have, I believe, moved it into this GitHub repository, but it is fine. But basically, we can see how they are able to connect it to Twitter, Wikipedia, and even OpenAI's function, petting zoo, and things like that, and a lot of other things. So you can create your own custom agents as well, and based on that, you can do that, right? Or you can actually go here, agent types, how to, I believe they moved it, but still it is fine. Um, but this provider is actually a good list for what LLMs you can use with it. So you actually get an entire list of what LLMs are available and are very popular in the market because they are always very up to date. You should go to chat models because base models are not very relevant to you, right? Um, oh yeah, here they are. So agents, basically you can see here, if you want to automate your Gmail, for example, that you get an email, it should automatically read that email and schedule a meeting for you if required. So you can use these agents, and using ChatGPT, you can automate all of that stuff. If you want to kind of write Python code just by prompting in English, you can integrate it with this. And this can actually run this code as well. So these are a couple of things that you can do with it. And this is the same for every uh, toolkit that you have that is available. Now, one of the major problems using these LLMs and ChatGPT is that you can at the maximum send 4,000 tokens in one time. There are models available with 16,000 and 32,000 context limit also, but like they are either not good or they are very costly. So the way to solve this is that you should have some sort of database, preferably a vector database. Now this is another exercise for you where you should explore what vector database is. You store all of the data. So this data will be from an organization. For example, if NVIDIA wants us to build their large language model based agent, they will provide us with the PDF documents. We will parse these PDFs, extract text, and save it in the database. Now just by querying, which is the nearest matching document um, to our query, by using the word embeddings that I showed, we give that document as context to this LangChain. LangChain will create a prompt, go to open AI, and using that it will give out the answer. Right? So that was for LLMs, how you can start with LLMs. And basically what all is there in the LLM part, right? Moving forward, we have this example wherein we tried to enhance the user experience using LLMs and recommendation engine. Before we actually proceed further, is there any question that you guys want to ask? From the things that we have covered up till now, any question that you have? You can type in no if you have no questions, so that I know that we can move forward. I think we should just move forward in this case. All right, Rashmi says no. Thank you. Actually, I think we should not cover this because this will just confuse you, right? But basically, if I show you the end thing that we have, we were able to combine recommendations that we usually give in a website to the user that is walking in. So we give the ability to kind of suggest questions to the user. So like instead of giving documents to the user and wanting the user to consume them completely, we give some suggested questions to the user so that the user does not have to do any hard work when the user is on our website, right? So using these questions, we are obviously able to generate answers, right? And like so that the user gets to know more about our organization, our products, our services, without having to involve a marketing person in between, right? So this is how uh, we were able to kind of uh, uh, ease out the journey of a user on a website, and also like to get more engagement from a user, because of course the user will be a lot more interested. Instead of having to go through a sales pitch, which is often very long, the user can just ask questions about what exactly they want to know. And if they have no idea about what they want to know, based on the web pages they have consumed, the web pages they have live, they have read, they've gone through, we are able to suggest them with questions like what could potentially you be wanting to ask, right? So this was also combination of LLMs and everything, LLMs and recommendation systems, and some traditional NLP components like named entity extraction, key phrase extraction, and things like that. So this I thought was quite interesting. It is 2:30 now, so I guess it is right time now to introduce you to Kaggle. So do you guys know about Kaggle? Again, type in the chat box so that I know you guys are not asleep. Guys, are you sleepy? Like, are you not able to follow through the presentation, or is the delivery not right? There is a communication gap. I need you guys to speak up. Like, is there any issue? Yep, we use datasets from Kaggle. That is true. We use datasets from Kaggle. But Kaggle is not only for using datasets. There are a lot of other things as well. And it can be a very good resource for you to learn data science, ML, and DL. Yep, there is competition also, where you can compete with your fellow data scientists and see where you lie there. And of course, it gamifies all of your data science stuff, so you can kind of enjoy while you're learning, right? That is quite cool. Is there anyone who is not able to follow through? I mean, uh, or anyone who finds that this content is quite tough and or boring. Um, okay, if I flip it, okay, it is interesting. Thank you, Rashmi. All right, I believe in the interest of everyone's time, I'll just move on to Kaggle. Um, so in Kaggle, when you kind of, even if you do not create an account, that is completely fine. You get a lot of things. We get competitions, data sets, models, code. We have discussions as well, and we have courses. One moment. Thank you very much, Alpana. Right, moving back to Kaggle. So here we have competitions data sets. We can use models as well, like uh, what trending models there are in these uh, notebooks and everything. Then we can have discussions as well, wherein you can ask questions about data science, or you know, you can join a forum. So for example, if you are interested in image processing, you can just select computer vision from here, and everything tagged with computer vision will come here, and you can start, you can join this forum, or you can actually just go through it and learn from that, right? There are courses also. These courses are like pretty basic. So if you want to start with this, it is a good place to start, to be honest, and you get to learn a lot from it. So if we move on to competitions, we see that, these three competitions are always there, because every data scientist that starts his or her journey starts with one of these three data sets only. So what I'll do today is I'll walk you through the Titanic datasets notebook that I was able to find, and then you guys can, have an hands-on and try it yourself as well. So we'll see what kind of exploratory data analysis you can do. I think Ritik sir yesterday walked you through data analysis and data visualization, right? So we will be following the similar principles, and using that we will be able to explore this data set and train a few models, right? So whenever we go to any of this competition, we have an overview tab. So this basically tells about the description of this competition, as in like what metrics they will use, or what is basically the data set about, and basically some metadata about this competition and what kind of submission file format they expect and things like that. When you move on to data, they describe the data for you. For example, if you have doubts about any of the column names, you can just go here and they will describe this for you, right? So for example, embarked is basically something that you might or might not, or even SIBS, SP and PARCH and things like that. This is very data specific terminology being used. So you can actually go here and have a look through it. This will help you to kind of understand this in a better way. And they describe it even further if required, right? If you go to code for any competition, you will see notebooks that are like very popular and like are made public by the users. So you can sort it by hotness, as in like which notebooks are like recent and very popular, or you can, oh, these are filters, or you can use filters as well. You want only the visualizations, you want it in Python or R language. Do you want to use GPU or do you not want to use GPU, right? You can sort it by hotness, most votes, most comments and things like that. I prefer public score and most votes. Most votes is basically for the notebooks with the best data visualization. So if I sorted by most votes, I will find out, notebooks with EDA. If I sorted by best score, public score, I will find out notebooks with the best models that they have, right? But mostly these notebooks just have the model. So at times when you open any one of these notebooks, you will not be able to learn much. You can just see how they use the model. Like this is all that there is in this notebook, right? So not much learning, but still, if you want to know what model they used and how they use this model, you can go through these notebooks as well, right? Um, right. So for example, this is one notebook that I found is very interesting. So we'll just walk through it, how they have leveraged matplotlib, seaborn, pandas, and all of this to analyze this data, right? This also talks about the stages that you want to consider. I'll share this link as well. want to follow through along with me. Not this one. House price, and similarly there is space time as well. Right? So I'll just close these two as well. So because they are not really relevant. So these basically tell you about the workflow stages as well. So this notebook is particularly very good because the author tries to walk you through every step and why the author is doing what he is doing, right? So first is you have to ask questions and you have to define a problem, right? The second is that you have to acquire the data set used to solve this problem. Third is to wrangle and prepare this data and do cleaning if required. Fourth is to analyze and identify patterns. Fifth is to train models and predict. Sixth is to visualize and report so that if you want to use this model or go to a different model. Seventh is to submit the results. Now every data science problem, every MLDL problem follows a similar workflow, right? Unless you have a bandwidth crunch, every problem will follow a similar approach. And also in reinforcement learning, there are some differences, but I think you get the point. So then these are some exceptions that you might want to consider when you are doing. So basically you can combine multiple workflow stages. So for example, if you have to train multiple models, you might want to combine these two stages together, right? Or for example, you are sure that you will have the clean data set, so you can drop this stage. Or maybe you don't have to submit the results anywhere, you just have to report them and deploy the model on your own. So that is how you can kind of alter these as well. So in this, we can basically see what the problem is. Now this problem is actually formulated by Kaggle itself. So they want to simply predict that what is the chance of a individual surviving this Titanic mishap that happened, right? So they have given some highlight notes that on 15th April 1912, during the maiden voyage, Titanic sank after colliding with an iceberg, killing 1,502 out of 22,4 passengers, translated only to 32% survival rate. So now Kaggle has given us this note, but what we can immediately make out from this is that there is a bias in the data set. As in, like, there will be more rows for deaths as compared to the survival rate. So we might want to handle that if we are doing any analysis, right? Now in this notebook, I don't think that they have handled this bias, but ideally when you are building your models, you should be handling this as well, right? There are reasons that one of the reasons that the shipwreck led to such loss of life was that there were not enough lifeboats for the passengers and crews. So this gives us one direction that maybe we might want to explore what criterias were preferred when passengers were onboarding the lifeboat. Maybe women and children were offered the lifeboats first, or maybe P1 passengers, like the business class passengers, were offered this first. So this is one exemption. One assumption that we can make from this. And when we are doing our EDA and analysis, we can keep this in mind. So although there was some element of luck involved, still some groups of people were more likely to survive, such as women, children, and upper class. So again, like what I said exactly, but like still we need to kind of prove this hypothesis if this is right or not, right? So so this is the workflow goal, 7 major steps. Now this is kind of the task that you want to follow. These 7 steps is basically how you would want to follow that, right? So whenever you want to clean your data set, now the computer cannot understand textual data set. So the first thing you should do is identify categorical variables and either one hot or label encode them. Are you guys familiar with what one hot encoding and the other one is? Label encoding and one hot encoding? Awesome. All right. So basically, this is one of the first steps that you should categorize the samples using any one of these methods, right? You should correlate. So in pandas, there is df.corr. It basically gives you the Pearson correlation coefficient with all of the variables. Now, if you do you know about correlation concept? If not, I'll just show that to you. Oh, Google wants to know my location. I don't know. Correct? Right. So let us just take this example. So we have these as columns, right? And this is again repeating here. And this is mirror also. So we can just consider either the bottom half or the top half. So basically trill or trio if you want to talk in terms of numpy. So in this, it tells us basically in user rating, how much contribution reviews have on user rating, right? How much contribution price has on user rating, how much contribution year has on user rating, right? And similarly for reviews, we have the same thing. For price, we have the same thing. And for year, we have the same thing, right? So for reviews, of course, reviews will have 100% contribution to its change, right? But if we want to check reviews contribution with respect to price, this is the contribution, right? So what we basically want to do is check these correlating features. And if, for example, there is a feature which is 95% correlated with each other, we want to remove those because that is just adding one extra feature and some extra calculations, but it will not give us with any extra knowledge, right? We can convert like at times pandas data frames could contain numbers as string format. So we might want to typecast those completing. So in these data sets, many a times you find out that a lot of empty rows are present, right? So we want to complete them either by using mean. So for example, okay, this is a question for you. I have this Titanic data set, right? And I have some age columns as empty, right? And I want to fill in the missing values. So what all factors I should consider while filling in this age bracket? You can unmute yourself or you can type in the chat box. I will wait till 2:45 if you want time to think about it. Okay. The question is that I have this Titanic data set, right? Actually, let me just go to data here. Here. These are all of the columns that are present in this Titanic data set, right? A couple of age rows are empty and I need to fill in these. So what all things I should consider while filling in this age? Because if I just take mean of all the ages and just fill in the missing values, that will not be right? Because there could be some bias. So if I want to fill in this age, what all I should consider? It is 2:45, so now I'll wait till 2:47 if you guys need time to answer this. Okay, Rashmi says try taking the variance of data. Rashmi, can you unmute yourself and kind of um, talk us through why you want to take the variance of the data so that all of us are on the same page?
Because I think if you will be taking the mean of the data, then it may be biased towards the person who has greater some age extent or lesser some age extent. For example, someone is 60 plus or someone is below 18. So that will not be fair to go with the mean. So what I think if we are going to be with the variance, so we will be able to see this thing, how varied the data is. So that's why I was taking this.
Right. Okay. So basically, you mean to fill in the rows with the help of probability distribution and weight, right?
Exactly.
Okay. Right. That makes sense. Anyone else who would like to give it a shot? I see so many people. You guys should try it out honestly. This will help you as well, right? So that you know that you understood everything that is being taught here. Now, in data science, the good thing is the way anyone suggests is not always the right way, right? I may talk about some things, but that is just my personal opinion. You might do some experiments and get better results. So there is no wrong or right concept in this. So you should just take a shot and try to answer this. I guess that's a no. So we will proceed further. So the way I will proceed is basically I will check if uh, you know there are parents, children aboard the Titanic, right? This will tell me if someone's parent is also there. That might be a kid, right? So I will maybe take mean of only those subcategory where I only consider the children. I might consider uh, maybe the sex. Maybe that is helpful. I will have to kind of do some analysis on top of it, how the variation is there is. I will check for survival rate. So for example, we know that older people and middle-aged people are not able to survive. So based on this, maybe I will try to fill in these values. Even the ticket class might be helpful, right? Because or might not be helpful. We don't know. So I'll just have to kind of explore the data set first, and based on that, I will try to fill in the values. Now, some people might say that the best way to fill in these missing values is actually to train a model where the value is not missing, and then using that model to fill in the missing values. Well, you might agree to some extent, but at the same time, that is not the best approach, right? So of course, like everyone has different ways and approaches to answer this question. Now, for example, I have weather's data for each day and a couple of days data is missing, right? So how will you fill in those missing values? Like what are some ideas that you could think of for filling in those missing values? Um, all right. So the way I would do it is I will take either, a rolling mean of, previous 5 days and forward 5 days, or I will take mean of each year's temperature on that day, right? Temporal distribution maybe. Yep. Of course, like, yeah, you can definitely do it. So this is called forward fill. So Arjuna and Rashmi both tried and their answers make sense. Anyone else who would like to try? So Rashmi, I believe temporal distribution, you basically mean that on that day, on other years, what was the temperature, right? And based on that, you will fill in the value, right? Okay, awesome. Uh, right, so that makes sense. Anyone else who is trying to answer? or should we proceed? I guess we are good to go. So now we complete the data set. We correct the data set if there are any spelling mistakes, or manually when you are entering data, maybe you can create two categories of one category. So for example, survival could also be written as survived and also SUR if there are a lot of humans in loop, right? So you might want to analyze that and correct that to create only two categories. You can create new features if there are any available, but that is not always kind of necessary. Then finally, you have to choose the right tool for charting. And of course, like creating new features requires a lot of domain knowledge. And this is what is a separating feature from all of the other notebooks, right? Because there is a competition. A lot of good data scientists are taking part on the same data set. So why everyone has different results? It is because everyone creates uh, different kind of features, and everyone uses different set of hyperparameters. So that is why you get different results, right? So we import all of the libraries that we want: pandas, numpy, cbond, matplotlib, and sklearn again, because we will be training machine learning models only. I did not want you guys to kind of get into deep learning just yet. We acquire the data, we import the training and the test data set, and we just combine the data also. We analyze what columns are there and we validate if the column names are matching with what had been given to us, exactly the same, or is there any difference in that, right? And we identify which one of these are actually categorical variables. Now they have given us this here, that these are the ones with categorical labels, but still we kind of do it anyways, right? We do a df.head to see how the data is looking like. Now, one thing that I can notice is that we have the surnames as well, right? So for example, if there is a sir someone, uh, the chances of survival might have increased, right? And I believe in this notebook they have tried to do that as well. Not sure, but we'll check that as we walk through. And we can see that there are some empty values. This NaN is basically not a number. Even if it is not a number, this is how in pandas you denote that this row is empty. So this is pandas way of denoting, right? We identify which of these features have a mixed data type. So alphanumeric is basically considered a mixed data type, like there are strings and there are integers both. So we either split it out if the numerical part of that holds any value, or we just treat it as a string and create it as a categorical variable. Now we have passenger ID here. Do you think that passenger ID will have anything to do with if the passenger survived or not? Anyone? The passenger ID. Do you think that it would be important if we want to classify someone when the name are same, I guess? Right, that will help us to identify, like the same question, exact. So passenger ID and name, do you think those will be relevant to guess if the person has survived or not? Just by using name and passenger ID. Okay, Jagmohan says no. Rashmi also says no. Lalita says maybe. Okay. Lalita, why do you think maybe, why not yes or no? Like, is there any doubt that you have, that you want to bring to all of us? Archana says no. Okay. Rashmi says we can try checking correlation. Of course, like we should never trust the data, right? Maybe the person who was handling live bots has some bias towards a particular name, right? Who knows? We need to check everything. Lalita, do you want to unmute yourself and kind of tell us why maybe like maybe there is some point that we are missing out here and you want to bring that up? Or just type in the chat box if you think maybe yes or maybe no, like what direction are you moving towards? Okay, Lalita has the same concern that, any variable may be treated as a marker. Maybe, people with higher passenger, or lower in this case, like higher in the order, might have gotten rooms closer to the passenger lifeboats. That is why they survived, right? So that is why we should consider this as well whenever we are correlating and everything. In this data set, it is not relevant, but still you should take into consideration that. But still, I believe this Mr. Sir and, these pre-names might be helpful to us. And we see that there are, again, some missing values in age column. In cabin column also there are missing values. Now this data set was prepared in 1912, so we cannot blame them, right? We have this data set kind of, is enough for us. So there is df.info. So we just print that out to check how many non-null values we have in total. So we see in cabin only 204 values were non-null, right? So we can either, remove this feature altogether because, if we have 891 entries and we have only 204 cabin data available with us, maybe it is not that relevant. Or maybe they wrote the cabin of only the top passengers. Again, we need to kind of check how the correlation is, right? So like I want you guys to kind of clone this data set and make your own notebook, try it out, and I'll share my email ID with you and come back to me with what your findings were, what we missed out in this notebook, if there was anything that we missed out, right? Or what are the things that you tried and what you assumed and that were actually wrong, anything that you want to share. So same thing in the test data set as well. Kevin has a lot of empty values. Then there is age. Age also has a lot of empty values, but I think we can work with that because we have some heuristic by which we can fill in these values, right? Right. So basically after each step, writing what inferences you have basically helps you in planning the kind of model you need in a better way, right? So here they have just written that only 40% of I'm sorry, is there a question? I guess no. Okay. Right. So here they have just written these inferences that out of the 2224 people that was described in the data set, only 891 or 40% of the actual number of passengers on board the Titanic, or maybe we do not have the complete data set, right? Survived is a categorical label with 0 and 1. Around 38% samples survived, representative of the actual survival rate of 32%. So basically from this subset 891, we see that 38 is the answer, but in the dataset description we saw that it was 32%. So maybe there is some dataset that they are holding to themselves, right? And similarly, we have a couple of more inferences with us that we can check, right? We have df.describe as well so that we can see what is the mean. So age, we can see that the mean age is 29, but I believe that is not helpful. top 25 people are in 20, 75 are in 38. So basically 38 to 80, there are in very few people with us, right? Then on 50%, there is 28. Right, so this gives you some example or some thoughts about how there is a bias in the data set. You can plot out box plots or whisker plots or violin plots to understand this in a much more detailed way if you want to, right? And it is a good idea. So basically violin plot is a combination of distribution plot and box plot. So just go with it if you want to do it. So now they are checking out the distribution of categorical features. So names are all uniques. So one hypothesis that we had that names might repeat, that is no longer with us. So 65% are males, so there is a significant bias towards males. So we might want to adjust that when we want to train our model. K-bin values have several duplicates across, and also we saw that there are, like, they are mostly empty. Embark takes 3 possible values. S is the most popular one. So embarked is basically where they got on. So Southampton is basically most of the passengers got on, right? Ticket feature has high ratio, 22% of duplicate features because only 681 uniques were found, right? So in this, when you do df.describe, this only describes the numerical values for you. Now, if you want to describe the categorical variables or string variables, what you can do is you can explicitly ask it to include those values. So here we can see that the categorical values, how is the distribution on top of it. So we can see here that male is the top one with frequency of 577. Ticket is top 1601 with top 7. Cabin is this one, and things like that, right? And you can see how much bias is there. Like on Southampton, basically 644 people out of the 889 got up. So once you are done with your initial part of EDA, you should make some assumptions that we have done initially only, but basically we can consider like we may want to complete age feature as it definitely has a correlation with survival, right? So before this, maybe they have plotted correlation map, maybe not. I believe no, they have not plotted any correlation map as such, but basically you should always map out correlation map to see how two features are correlating with each other. So whenever you are doing EDA, you should do univariate analysis and bivariate analysis both. There is multivariate also. So univariate is basically what we have done here, that we are exploring just one feature at a time. Bivariate is when we are comparing two features with each other, and multivariate is when we are comparing one feature with rest of the features, right? So completing is done. Correcting me, they have suggested that we should kind of drop a couple of columns which are either not relevant or have a lot of empty values. We might want to create a new column based on what family information we have. Oh, they are extracting the title. Awesome. We may want to create age bands so that we are able to group these age into categories. And we also may want to create a fair range so that we know, like, again, like categorizing these into buckets of rich and middle class and things like that. Finally, we want to classify, and again, a couple of assumptions that women were more likely to have survived, children were more likely to have survived, and P1 were more likely to have survived. Now, if there is a question mark, we basically have to analyze that children above what age were able to survive the most, right? So because we want to analyze this, so now our EDA from a generic EDA has shifted to more of a data specific EDA, right? EDA is exploratory data analysis. Now our EDA is to answer questions that we have about this, right? So we see that we basically create for each P class, what is the probability of someone surviving, right? So this is individual. So this is not dependent on each other because the sum is not equal to 1. But if you want to calculate that, you can calculate that as well. Like just from the class, what is the probability that P1 people have survived? And this we have the probability of if a person is P1, what is the probability that that person has survived? Right. Similarly, we have plotted this for sex, male and female. What is the probability of survival and non-survival? Similarly for CBSP, PARCH, and everything, right? So we see that, you know, these people had no chance of survival. Even these. So now we were able to kind of uh, able to answer a question that we had. So age less than 4 had high survival rate. Older passengers age 80 survived, and a large number of 15 to 25-year-old did not survive. Right, and most passengers are in the range of 15 to 35. Right, so like this is a sad part on its own. And then we plot out the distribution of what is the age and what is the probability that someone has survived. Right, and we just plot it out. Oh, not exactly. Here we are plotting that if the person has not survived, what is their age and how many of them are there, right? Because we are pinning them, right? So that is what we are trying to plot. So we can see that most of the people that did not survive are in the range of 15 to 35, which kind of, 15 to 25. Well, it is hard to read this way. Maybe they are just considering till this point. Again, what you think is right. Maybe you consider the point still here that 15 to 40 did not survive. It is completely up to you how you want to um, do your analysis, right? So then we have some more observations that P3 class had most passengers, but most did not survive. So basically, our assumption that higher class passengers have higher chances of surviving is true. Now, infant passengers in P2 and P3 mostly survived. Now, this further qualifies our classification assumption that children mostly survive irrespective of the class. Most passengers in P1 class survived. So this basically tells us that if you had more money, you would more likely to be survived. And P class varies in terms of age distribution of passengers. So basically it varies. So we cannot take into consideration that. Similarly, now we see for each P class, what are the chances of surviving or not surviving and how many people were there. And we are able to kind of infer. So for example, in this P3 survived 0, most of these people were here, right? And for P1, most of the people survived. And so we can make a couple of inferences like this so that we are able to handle what kind of effect these features have on each of the columns, or like the column that is important to us, which is whether a person survived or not. Is everyone following till this point? Yes, thank you, Jagmohan. Okay, Lalita and Rashmi are following. Any doubts till this point? Is it even interesting? Like only 2 or 3 people are लिसनिंग? बाकी सारे सो रहे हैं या फिर सारे सुन रहे हैं? ओके, नो डाउट. अच्छा, किस किस को नींद आ रही है? इट्स फाइन, यू कैन बी completely honest. Archana has no doubts. Awesome. Lalitha is trying to understand. Lalitha, please stop me wherever you feel you're not able to understand, right? You can just unmute yourself and stop me right away. Is Meenakshi back with us? I believe still no. उसने class लगा के छोड़ दी. It is fine. All right. So are we good to go forward? Last chance to ask questions till we cover the second part, I guess. For some reason, मेरे message में notification नहीं आ रहा, so I'm not able to see. All right, so we will move forward now. All right. So similarly, we plot out like based on gender if there was any kind of bias, and also like if where they got up had anything to do with their chances of survival, right? So these are just fancy plots that you can do to beautify your notebook. You can use Plotly as well to beautify it even more. But you know, if you just are trying to analyze just by using a set of 2 or 3 different types of charts, you can easily do this EDA. So doing this EDA is not usually the difficult part. Like what you want to explore, like deciding that is the difficult part in this. Right. Similarly, we have again embarked as survived, like combining these genders. What is the probability? So now we are kind of correcting. We are in the correcting stage. So basically, we want to create a new future. Basically, we want to get the title from this. So here are all of the titles that we have. So there is 1 captain, 2 colonials, 1 countess, 6 male doctors and 1 doctor, and you know, you can see here maximum of these are like Mr., Mrs. or Miss, right? And master are also a significant number. So we will check, like based on this information, did it have anything to do with the survival of that person or not, right? Now, because there is only 1 captain on the ship, do you think considering the title for this captain is relevant to us? Should we consider this captain as well? There was only 1 captain. Do you think it is worth learning? Do you think we should pass on this information to the machine learning model and it should learn from this? Rashmi says no. Okay. Yes, surely, if we can avert such incidences in future. Of course. Lalita says yes. Okay. So now, you know, if we decide to include captain also, or not only captain, like include countess and, you know, Dawn, even John here. So now this will create an unnecessary bias in our data set. We are not exactly sure. Captain can be of other ships as well, which may be traveling. Yes, true. Archana, that is true. So basically, my point being that captain may be important in deciding if the person has survived or not, but at the same time, this will create an unnecessary bias. Because we have only one row with captain as a title, we are not sure if this is just a coincidence or actually captain has something to do with this person's survival. Right? Everyone agrees? Yeah, Lalita, do you agree with this point? नहीं ओके वाली बात नहीं है, just like if you agree or not. If you do not agree, we'll look at it from a different. Yes, Lalita.
Yeah, my personal take on this is, you know, it was a accident of a mammoth, tragedy that happened, and we are learning of it. I mean, we are just trying to understand the data and come out with our own, recommendations of what could have happened if this happened, and I mean, if it was this and it was that. However, I mean, it was an accident notwithstanding, and we should include every parameter that would have effect on its understanding, without any reservations, no bias, nothing at all. Yes, if one captain was not enough, they should have gotten a second captain, or at least in future, we should always have a second captain. That should be the spirit, actually. So, but there will be no bias here whatsoever, because the incidents, the tragedy has already happened.
Right.
And talking of a bias, I think would be a little unnecessary. No way. If it was because of one single captain, then yes, we have to conclude that there will be more captains in future ships or whatever.
Right. Right.
I might sound naive, but then, yes, as I said, anything that would avert such tragedies to happen in future, we have to consider them.
Right. No, I completely
No reservations.
agree with your point.
Yes.
That is why, initially we started off with this discussion that we should analyze this passenger ID as well. Right?
Yeah.
So like this analysis, if the captain is important or not, it is good for EDA and giving out inferences.
Yes.
So now there is a difference between inference and what the machine is learning.
Okay.
Right? So like we know that machines are not very good at reasoning, and also they don't have any emotional or sentiment value.
Obviously,
Right?
yes.
So now if we decide to give captain as an input to our machine learning model, it would kind of deviate this machine learning model towards the bias towards this captain, even if there is not. Right? So this is where we have to bring in human in the loop, wherein we give this information that there was only one captain. So we might want to include two captains, or even in some other example, maybe there was two this and both of them survived. So maybe,
Yes.
there was some bias in this, but we cannot give this machine learning model this input because this will prevent our model from learning of what the actual causes were.
Well, we never know. I mean, the actual cause could have been, that the captain was all by himself or herself, whatever. So,
Right.
We
But
would.
these are again just assumptions that we are making.
Yes,
right?
exactly.
Exactly. So like our assumptions have to be on the basis of some inference from the data. So like we know that there is only one captain. So like assuming that adding captain to the model will not help improve the performance might be a justifiable assumption.
Okay.
Right?
Okay. Yeah.
But again, like captain is very important when we are doing this analysis.
Yes.
So we should actually, either try to find out if there was any other person of a similar ranking. Maybe we can combine all of these rankings, which are considered to be even search. Like we can combine all of these and we can see that if there was a bias in the designation of that person or the financial standing of that person.
Okay.
rather than the women and children bias that should have been there. So these are a couple of things that we can kind of
Okay, right.
explore from this. But this is just for the exploration part. When we want to train our machine learning model, because these machines are very good at rote learning, मतलब वो बस रट्टा लगा लेते डेटा का अच्छे से. तो उस केस में our goal is of course to find generalization, but still अभी तक we have to guide these machines. Deep learning model में we can send in captain as well, because deep learning models are good at generalizing and kind of giving importances to features based on their correlation with the output variable. But unfortunately machine learning models में जितना हम उनको इंजीनियर करके देंगे वो उतना ही उसको समझ पाएगा अच्छे से. So I in fact have, I believe, one presentation. This is all hypothesis testing. Maybe it is in this drive. Not able to find. चलो never mind. Basically if we go to this example, अब यहाँ पे हमने देखा कि फेस से उसने आईब्रोज, आईज एंड फेस ये फीचर्स एक्सट्रैक्ट कर लिए खुद से, बिकॉज डीप लर्निंग मॉडल्स आर वेरी गुड एट इट. बट मशीन लर्निंग मॉडल अगर हम ट्रेन कर रहे होते हैं तो हमें उसे एक्सप्लिसिटली ये वाले फीचर्स एक्सट्रैक्ट करने पड़ते हैं मैनुअली, एंड फिर वो फीचर्स देने पड़ते हैं. आई थिंक रश्मि आपने ये क्वेश्चन भी पूछा था सुबह, राइट? सो मशीन लर्निंग मॉडल्स में आपको ह्यूमन इंटरवेंशन काफी ज्यादा करना पड़ता है, वो काफी सारे फीचर इंजीनियरिंग करनी पड़ती है, आपको बिल्कुल ध्यान रखना पड़ता है कि आपका डेटा बिल्कुल सही हो. बट डीप लर्निंग के केस में आपको बस ये ध्यान रखना होता है कि आपका मॉडल ओवरफिट ना करे, क्योंकि मशीन डीप लर्निंग में मॉडल को ओवरफिट करना बहुत आसान है, बिकॉज इट इज एबल टू, yes, more data creates more impact. But to answer your question, Lalita, what we can do is we can use deep learning models to avoid this kind of human-made bias. This is not including captain is my human bias, enough. So if you want to remove that and we want to do this analysis just on the basis of data that we have, we can train deep learning models in that case. Did that answer your? Okay, awesome. All right, so they basically just grouped these not commonly occurring categories, and they just plotted out the probability distribution, and we find out that Miss and Mrs. both of them have high survival rate, and then again Master has a high survival rate. Misters have very low survival rate, and Rears they don't have any special benefits being given to them if they will survive or not, right? So now, based on this thing that we have, we will create a new feature with the title as a categorical variable, right? So finally, we will kind of label encode our sex also, and we will try to complete our numerical features, right? So for this, they have a custom logic wherein we can see here that they tried out different ways by which they want to fill in. Even your approach, Rashmi, I believe. you suggested that we should take into consideration the variable, right? Not sure. Yes. So basically they have tried this thing as well. Now the goal in Kaggle is to improve the score. This is not a real life competition. So they don't care about what the machine is learning. They just want high score. So they have tried all of this, but in real life, what you'll do is you will choose what is best for the outcome. So for example, if we had been provided with this Titanic data set in real life, because it has such huge sentimental value associated with it, and a lot of people are looking forward to us, we have to be like super sure that every step that we do here makes sense. Here they just filled it with median, but I mean, if you kind of consult with some domain experts, they might, not um, agree to this point. Now they have uh, taken the subset of sex and P class, and based on that, they have uh, filled in this age with the median. But you can, of course, consider other categories as well, right? यहाँ तक clear है सबको? Any questions till this point? Okay, I'll just take Rashmi's word for it कि आप सबकी तरफ से उसने बोल दिया. So we will move on now. अब हमने एज बिन्स बना लिया, राइट? एक एज बिन हमने बनाया है कि 0 ग्रुप में हम 16 साल से नीचे वाले बच्चे डालेंगे, देन 16 to 32, देन 32 to 48. इसमें ये ध्यान में रखना है क्योंकि 16 यहाँ पे इंक्लूड हो गया, तो यहाँ पे हमने 16 को इंक्लूड नहीं करा. 30 to 48, 48 to 64 and above 64, right? So basically we have created this age band here. Now this should be kind of हमने मतलब एक और फीचर ये भी डाला है, एज बैंड क्या उनका, एंड एज ऑफ एग्जैक्ट वेरिएबल की जगह हमारे कैटेगोरिकल वेरिएबल्स आ गए. दिस माइट वर्क, दिस माइट नॉट वर्क, क्योंकि हमने देखा था कि सिर्फ 4 साल से नीचे वाले बच्चों की प्रोबेबिलिटी हाई है, 16 साल से नीचे वालों का कोई लेना देना नहीं है. तो बेस्ड ऑन दिस वी माइट वांट टू चेंज हाउ वी आर categorizing or how we are creating these bands. Maybe we can create them on the basis of probability or anything that you think that is important in this. Right? Then they create family size by combining siblings and past and +1 because they want to include that person. And we can see that people with large family and also with small family had less chances of survival. 3 to 4 family size was ideal for surviving Titanic. So now based on this family size, we find out who is alone in this case. And based on this, we again check if the probability is any different or is alone in further. Similarly, we just add out these classes. We fill in our missing values, as in like we fill it like with the maximum, like the mode which is occurring the most. We fill it with that. Wherever it is empty, assuming that this is again an assumption that the traffic was so high on the S port that they missed out filling in, and assume that they will just assume. But again, like domain expert is important for that again. Right? So they have created this feature here where they have multiplied the age with the class. Do you think this feature is important or relevant in our case? Guys, I'm waiting for you to answer. Okay. The question is that they have kind of multiplied the age and class together, right? So now my question is, do you think this multiplication is actually helpful? Will it provide us with any extra information? Like, did we have to do it? You can take your time, Sven. It's fine. I'll stay on mute and we'll just take a break for 2 minutes. You guys can think this through if it is providing us with any. Hanji Nalita.
I would think it is it is to avoid the categorical nature perhaps of age and give a definite, and create a definite parameter.
Mhm.
Because categorical doesn't actually say much or speak much.
Right.
So this multiplication would have age into class could have, yeah, the variations are from 3 to 6. There's a bit of categorical nature here also.
Right. I mean, the whole point of having label encoding in the first place is to give higher weightage to certain categories. Because
Yes.
now our machine learning model will think of 6 that it is more important to us, right? So that is how ideally we should label encode if we are doing it. So in a way, yes, we are kind of moving this age uh, from like just categorical and we are adding in extra information so that we have more labels to work with, right? So what I would assume why this author has done this is like the original reason is with him only and we can just assume why he has done this is because, and maybe he has mentioned in this notebook somewhere and we have skipped it through. I have shared this notebook with you and I'll give you some time to go through it and ask questions. So the reason they are multiplying this age and class is because one goal is to also reduce the features that we have. And we do not want our algorithm to learn too much because as we have discussed multiple times already that machine learning is not very good at kind of making generalizations, right? The other part is to kind of combine both age and P class, what you said, Lilita, so that we are able to give higher weightage to those who are younger or not exactly younger, but ideally we should have given more weightage to who are younger and in P1 class. Right? This will give more importance to who are in P3 and older, right? But the way we should have multiplied this is who are in P1 should have gotten more weightage and age who are younger should have gotten more weightage. Right? So in case of label encoding also, we saw that younger children were assigned with a 0 label. So maybe our machine learning model learns that wherever there is low this number, we have to give higher weightage to that, or maybe it does not, right? So to be on a safer side, maybe we could have, you know, uh, exchanged it a bit so that younger people would have been assigned with 4 to 5 and older people would have been assigned with 1. It completely depends on what kind of model you are training, right? Because logistic regression is not that intelligent, if I should put like that. We will be not able to capture this, but if we are using decision trees or random forest, even this representation we'll be able to capture in our model, right? So in this way, our model will learn that the lower the score is, the higher the chances of survival are, right? So we are basically combining the goods of two features. Was that justifiable? Like, do you guys all agree? Or is anyone kind of still confused or, do not agree with my points? Anyone who would love to counter? Please counter if you want to, because, either, my idea will convince you or your idea will convince me, right? Because while giving this lecture only, some of Lalita's ideas actually made sense. And I realized within this lecture only that maybe we could have approached this problem in a different way. Even while talking about this thing, where I was initially talking about how we should have given higher scores to age for lower children, I realized that decision trees and random forests do not work that way. So if you are countering me, you're not only, um, you know, validating your reasons, but also you are kind of extracting more information from what I have gained in my 3 years of experience. Are we good to move forward? You can type in the chat box yes or no, if we should move forward or we should wait. I am audible, right?
Yes, Anchit, you are audible. Yes, we can move forward. Yeah.
Okay. Right. So in case of fair as well, we just fill it with the median because, not a lot of values are missing. So this all we are kind of trying to complete our data set, right? So now we have reached our final stage wherein we want to train a model, we want to predict, and we want to solve this problem. So because this is a classification problem, we can rule out some models completely, like linear regression or, couple of other regression models, like even decision tree regressor is there, random forest regressor is there. We just want to use classification models and even clustering algorithms and unsupervised algorithms. We can ignore that completely. So here we have created our training and test splits, right? So basically we have just used the training DF and test DF as is. Ideally, we should combine these first, shuffle them, and then use it if we want to get better results, because there could be some bias if, they have split the data set based on the index. We might we might, get through some bias or something like that. So they have now started to train these basic models, started with logistic regression. They get an accuracy of 80.36, which is not that bad, but like we could get better because logistic regression is a very basic model. So the way you should approach these problems is basically you should have a baseline model first, and then you should try to improve on that and get better accuracy so that you know that if you are improving or not, right? Baseline model should be like super simple, like just take the data, train a model and save the results with yourself. We get the correlation coefficient from this. So like logistic regression gives us which of the features are important and which of these are not important. So we see that how sex has the highest correlation followed by title and age, right? And P class has negative correlation, which is also good because we need something to counter also, right? It also in a way kind of is helping us to make our model learn in a better way. So we use similarly support vector machines. Now we are at 83.84. So we see that how increasing the model complexity also increased the accuracy. There is KNN. Let's just move on to random forest or decision tree because those models are pretty good when it comes to complex learning. So we can see that we've already reached 86.76, and this is without any hyperparameter tuning. They just use the default set of hyperparameters and they are getting 86.76, which means that we can, improve our accuracy by a lot. Now in random forest as well, they have used the default features. They have just used 100 estimators in this, and we can see that the accuracy score is like quite similar, which means that, random forest using this might not be really essential, and we could save some computation. So we can just go ahead with decision tree and try to hyperparameter tune our models. And finally, they have this table here where they have ranked all of these models based on the accuracy, and we see that naive bias is at the last. It is at the last because naive bias is like quite simple. Then we have perceptron. Logistic regression is somewhere around here, and we can see how it is increasing the time. Right, and finally they have submitted it. Any questions in this notebook? So from my side, this was all that I wanted to cover for the theoretical part. Now for the hands-on part, I have already shared this link with you. You can either kind of go through this notebook in your own time for the time that we have left, or you can try and clone this notebook and do your own EDF. For example, you think that anything is missing or you would want to achieve this in a different way, different manner. You can try that out, and I'll be in this call in case if any questions are there.
So yeah, this is a good time for practicing and checking out all the links because we have covered a lot of areas today. And please, we'll hang out for some time before we hang up, and maybe 10-15 minutes, okay?
Mm-hmm.
And you do check and let us know. If you have any questions, doubts, any of the things, the concepts which you did not understand. Yeah, Ritik is also there. Hey, Ritik.
Hey, Ritik.
Yeah, hi.
Fair enough, Anchit. Thank you for your time, man. Like it was great having you here, and we surely do connect. You based out of Delhi, right?
Yes, I am in Delhi.
Okay. I'll surely catch up with Ritik and me sometime.
For sure. For sure.
Yeah.
All
When
right.
is Sarabjit sir coming back?
He will be here on Monday, I believe,
Okay.
if his plan has not postponed. The last I spoke with him, he was supposed to come on Monday.
Okay. Sure, we'll do that. And everyone, Sachin sir is he here? Sachin sir? Okay, let me
I
call him.
believe. No.
Anyway, we'll hang up for a few minutes. Yeah.
Mm-hmm. Super cool interacting with you. Thank you for having me here, Satyakam sir and Ritik. It was really great being here. Let me know if there are any doubts.
Sure. Thank you.
Thank you, Lalita.
Confirm some.